Hello, everyone. Welcome in. Happy Monday. We're going to be doing part 2 of writing a machine learning language framework from scratch, and it's going to be the backpropagation, which is the hardest part. The hardest part. I've been struggling a little bit to remember after many years. It turns out there are so many different ways to do backpropagation. I mean, there's like a common pattern that you need to implement. The challenge is it's actually kind of exciting, neat, but also got to be careful, because it could be that you implement it in a way that it kind of works, and it mostly works, but it won't work for all scenarios. And so trying to make it work in a cohesive pattern, that's the challenge, and that's the trick. Because I've written multiple over the years, over many years, I've written multiple frameworks that do backpropagation and machine learning. But it turns out some of those frameworks they only worked in their very specific situations. They didn't always work and some varieties of patterns. But it's actually very forgiving, which is good. But also there's some things that it's not forgiving on, right? When you're building your own machine learning framework. So you got to be careful. But what we're going to be doing today is backpropagation. We're going to be doing backpropagation today. I'm really excited about it, but it's the most challenging, most difficult part. And trying to get it try to simplify it is part of the challenge, because I like simple. I like keeping things simple, and it's very easy to write of complicated and heavily utilized. Hey, good morning, Blue. How's it going? Yo-ho. Welcome on in, Blue. We're going to be doing backpropagation, which is part 2 from our machine learning framework that we did on Friday. I've kind of worked it. It is the most challenging part. It is absolutely the most challenging part. It's actually really exciting. But I think, so I did a little bit of studying just before stream here. And I wanted to see, and we also have a reference file. And this is hard most. The AI is turned off. And we need to be able to finish our framework today. That's the plan. We should be able to do it. We should have a minimal working framework. I remembered it. I remember from the understanding and how it works. And so we're going to be doing the backpropagation part, which is the most difficult part. Forward propagation, super easy if you remember. Check this out. Forward propagation is the easiest part. It's really straightforward. So here it is. Here's forward propagation right here on the screen. A very simple implementation. Oh wait, yes, here we go. Yeah, forward propagation. Doesn't that like make sense here? So wait, hold on a second. I think I want to simplify this. I wanted to do this, I think. There we go. So we're saving our inputs for backpropagation later, and then we take our inputs, which is going to be, from the input on the input data to the model. And then we're going to be multiplying it with the model weights like this using an outer product. And then we're going to activate it, which is just tanh, what we have. There's our tanh right there. So that's what we're going to do. And so the part that's incomplete, the part that we need to finish today, which I'm not sure if we're going to make it. I don't know. I don't know for sure, but we might make it. So here, let's actually get things going here. We need to, but another thing that I'm not doing right now. Hey, Chad, how's it going? I'm hacker, bro. You excellent. Very nice. I'm sorry, but are you AI? Oh, good question. Is this AI? This is, we're live right now. We're live. This is, we are not AI. Well, I mean, who knows? Is this a simulation? Because we could be AI. Our NLP professor was introducing backpropagation 2 today. No way, really? It is the most challenging part to the machine learning aspects. It is the most challenging part, especially when you're trying to create a simplified framework. And see on the screen here, the code is actually pretty clean. I like it because I made it. Not Owen, hey, how's it going? He might be AI. We might all be AI. We all might be AI if we are in the simulation. No, who knows? I mean, we're looking at that Sora app on the iStore or the Apple Store, and we're getting close to indistinguishable reality that we can generate all on our own. So it's kind of crazy. You guys. All right, so here we go. So what we're going to be doing today is the backpropagation part. We're going to be, Chad, I can reveal your phone number. Ooh, really, Chad? Wait. Do you know my phone number because you just happen to know it? Or because that could be a problem. Reveal. Oh, wait. 1 plus 1, ... Well, okay, yeah, US. Okay, you've got the US code. What's the first? Here, actually, Chad, what you should do is, what's the next number? What's the next number after that? Hey, Zeke, how's it going? What a cool C# project should I do for my assignment? Oh, Zeke, you should do a simple machine learning algorithm. I think that would be really fun, Zeke. Do something with AI. That should be your project. Do something with AI in C#. I think that would be really cool. That'd be really satisfying. That's what we're doing right now. We're doing it with Python, though. We're doing it with Python. Chad, what's the next number? I'm curious. What's the next? You could probably find this on the internet. You could probably find it on the internet somewhere. But if you get the next number right, then it'll be, oh, okay, you probably really do have my phone number. All right, here we go. So what we didn't do last time was we're not using the bias, and we need to be using the bias as well. So let me see here. So let's copy the bias over, self.bias. I think we have to do it like this. There we go. So we have to include the bias here, and that will be part of our forward pass. Part of our forward pass, and we're saving the inputs for the backpropagation here. We're saving the inputs for the backpropagation. Here we go. Okay, so what I need to do is, this part is wrong. This is totally wrong, and we need to fix it. We need to fix this part. We need to calculate... Guy with glasses, hey bro, how's it going? Welcome in. We're going to be doing backpropagation today on our machine learning framework that we're writing from scratch. We turned off the AI. We're in hard mode. We do have a reference file that's right here. Look how complex this reference file is. We're going to try to make it simple. We're going to try to make it simple. This is complex. This is simple, right? Looking at the difference, right? Complex. We got simple. So we're trying to make it easy. I think if we make it really easy to understand and see, and the code looks clean and clear, then we'll help everyone. Not only will we help myself, but everyone who's watching, you're going to see a simpler version of backpropagation. And I think that'll be really, really meaningful. So let's print our loss. So here we go. This just, since we're doing a batch, this is a batch of data. We want to calculate what the loss is across the batch and print it. We're not going to be using this for anything. This is just for usage. This is for our knowledge. We want it to approach close to 0. This number needs to approach close to 0 to show that the model is learning. If it doesn't approach 0, or if it goes the opposite direction, then something's broken. You guys. I would love to see the horizontal live. Oh yeah, I know what you're talking about. We have what is it? It's 1080 by 1920. It's like the opposite. It's the opposite way. Maybe someday we'll get to a horizontal live. But today, here, this is what we got. So I don't know if you can see here. This is the view. And so the canvas size is the resolution of the opposite of it's the vertical view. It's the vertical view. Someday we'll get it. But today we'll be focusing on backpropagation. Okay. So here we go. Did you watch Mr. Robot? I did, Chad. I did watch Mr. Robot. It's a really good show. It's really good. It's worth it. Hey, Abir. Hey, Abir, how's it going? Welcome on in. We're doing backpropagation today. This is a guy with glasses. Fire emoji. Cool. We'll someday we'll get it. I promise. We'll see. It's pretty easy to switch it. But for now, at least we're vertical. We're in vertical now. Okay. So we're printing for loss. We've got our delta, which is just the error. This is like the error. I call it the delta, to see how wrong the model is when it's prediction. We need to calculate. Okay. First thing, before we backpropagate, we have to calculate the first gradient. The first gradient is going to be the error times the derivative of the output. Okay, so we have to do the first gradient. So we've got the delta, which is also the error. So we've got the delta. I want to make this better. Don't get me wrong. This part is going to be a little tricky because I want this calculation to actually be occurring here in the backpropagation, because we have to calculate it again in the backpropagation. But the first initial gradient, since we're only capturing the inputs, we have to calculate the first gradient of the output in the last layer of the forward pass. So here's the gradient times the last layer, C dot derivative. And then we need the output of C. Okay, so the last output, here we go. There we go. So this is the first gradient. First gradient. And it also is calculated a little bit differently when we pass it in the backward pass for further layers. Lebac, how's it going? Could someone explain, please? I'm a noob. Okay. We are doing backpropagation in AI, which is the part where the AI learns. This is the learning part, the machine learning. Because you can have an AI that doesn't learn with a model, and you just do forward pass. You don't need any backpropagation, gradients, calculations, or errors, or anything like that. But the learning part of machine learning is the backpropagation with the optimization. So that's what we're doing today. That's the plan today. We want to make it work. I don't know. We're going to try our best. We're going to try our best because it is one of the most challenging parts to machine learning is the backpropagation. So we'll get close. I know we'll get close. We even have a reference. I don't know if the reference works. That's what we're making. That's what we're doing today. Yes, Lebac. Excellent. Very cool. Okay. That's the plan. So here's our gradient. Then we can pass the gradient into the backpropagation of the first layer of the last layer, because we in the forward propagation here you do forward across multiple layers, and then you get the final output, which is basically the answer. This is the answer or the AI's answer in quotes, answer like that. Yep, there we go. Okay, that's what the answer is. Thanks. Yeah, no problem. Hey, fall off ladder. Ouch. Fall off ladder. Ouch. Awesome. Cool. Your name's really funny. I like your name. That's the plan. Lebac, I'll try to keep up. Okay, cool. If you have any questions, let me know. I'll be happy to answer, but that's the plan for today. So we have the forward pass, which is really easy, which is just basically, it's this right here. It's this all in one line. This all right here, all in one line. It's super straightforward. It's this right here. So we take the activation, which is just the ability to keep the numbers in check because we don't want the numbers to get too big. Activation, we want them to stay in a certain bounds, so that way if they go the wrong direction, they can be normalized. This is called the normalization. It's called the normalization. So that way when we're as we're passing data for the inputs and through the forward passes, we don't want the numbers to get too big or too small or, those sorts of things, because you can have issues. This only gets us part of the way there. There are other tricks and other items that we can use to make improvements to reduce vanishing gradient and exploding gradient problems, but we don't need to worry about that today. We're just keeping things simple. So you take the input, which is the like say a book or an image, right? The input data, like an image or text or numbers or something like that, and then you multiply or do a outer product on the weights. Hey, how's it going, Sohom? How's it going, Sohom? Welcome on in. We're doing backpropagation today, and then you have a bias, which is the same as the weights, which is but it's a two-dimensional array versus was it 1, 2, 3? Yeah, one-dimensional array versus a two-dimensional array. And the bias will just help. I don't know. I don't really know. It's just a common thing. And you can do bias so many different ways. Hey, Idris, how's it going, Idris? Welcome on in. We're going to be doing backpropagation today. Okay. So there's a lot of different ways to leverage bias. But we're trying to do it with the industry standard approach that also works in multiple scenarios. You could just add bias really simple, but we're going to do a one-dimensional array bias, which is defined right here, one-dimensional array. And here's our weights, which is the parameters. If you hear like these large language models, they're like 1 trillion parameters. That's what this part is right here. That's what this part is. They're just numbers. That's when they say parameters, it just means numbers. They're essentially the coefficients or the constants, or the weights or the biases. They're all the same thing. They're just numbers, you guys. They just have all these different fancy terms, and it's just a number inside of an array. That's all it is. It's really simple. It's really ridiculous. Now we have to do the hard part, which is our backpropagation. Okay. So we did our gradient for the first gradient, which we're capturing here with the derivative of C derivative, which is so we defined multiple layers right here, layer A, B, and C, right? So this is our model. This is our model, right? And it is a multi-dimensional, like 3-dimensional, multiple layers. And notice this is actually really critical. Check this out. See how the output layer right here, number 4, matches the input layer on the next layer? That always has to happen because of how the matrix are multiplied. If they're not the right shape, they're not compatible. Drawing Brothers, hey, welcome on in. We're doing backpropagation today. If the numbers, if they don't match, then so like what you could do is you could do a 6. Thank you for the likes, you guys. You could do 6 and 6 like that. You have to make sure that the input layer matches the output layer like this, because it's going to become the input layer for the next layer. So you have to do something like that. So that is important. Chill with the code. It's not that serious. You're right. You're totally right. It's just code, you guys. It's just code. And guess what? We're doing hard mode. Thank you for the likes, you guys. Abdul. Hey, how's it going, Abdul? Welcome on in. Harsh Vardhan. Love your content. Thank you. Thank you so much. We're the plan for today is machine learning. Yeah, I saw the like show up there. Thank you. Thank you for the like. Okay. Machine learning. All right. We're making it happen. And then we'll do the backpropagation, and then we'll also do the optimization. We'll probably have time for that today. And so you can see how clean and simple this looks. Compare that to this. Look at the screen. This is the reference that we're going to be working from because we are not using any AI. We're going to be only using just some reference code because look at the complexity on the screen right now. What's even happening here? We're going to try to make it really simple. The Quiz Club. Good God, I'm late again. No worries. You're actually pretty early because we're still just getting started for the most part. The only thing that we wrote was this part right here. This is the only part. We only wrote 1 line of code so far, so you're not that late. We have to calculate the first gradient to pass into the next layer, right? So then we're going to have grade. We don't have to. Let's see here. I think we have to do it like this. So the gradient will keep being passed onward like this. So we'll do something like this. So B and then A. So we're going backward, right? So we did forward propagation ABC, and now we're going to do CBA, right? We have to do it like that. And then we don't need the last gradient because it's not used anywhere. We don't need it anymore. But I do want to copy and paste the gradient here every stage. Here we go. There we go. So we're going to do, here we go. I have a question. Okay. Abdul, what do you got? I have a question. I would like to make inquiries. Hoping you can help. Okay. We'll give it a try. Maybe. We'll see if we can make it happen. Maybe. We might be able to make it happen. Okay. First gradient, and then let me do propagation? Is it propagation or propagation? It's like this. Here we go. Okay, then we do the actual backpropagation. So it looks like this. So see how clean and simple this looks. We're gonna make it simple. We want to make it clean and simple because this is just a lot to deal with. Okay, so we've got our first gradient, printing it out, and then we're going to do our actual backpropagation. And then we want to save. I think we want to save the gradient so then we can do optimization afterwards on each of the layers. Or we could use the optimization directly. We might be able to do the optimization directly in our backpropagation, which, I mean, might as well. Who knows? Are you using AI to extract content from your live? To extract content from your live to upload to Shorts? Yes, because the revenge shorts were just pointless ones. They were the revenge short. This is just a genuine concern from my friend who I suggest your channel. Okay, cool. Yes. So you're right. I do have an AI that sort of goes in and looks at possible shorts to extract using some tool calling and function calling. It does work. But you're right. It doesn't always do a good job. And so I have made significant improvements. So over time, Actually, I do need to write that down. I do need to make another adjustment to the algorithm, but it goes out into next year. So there's already enough shorts that are planned out until next year. Already, automatically, the AI went crazy, but I've already made improvements. And so you'll be seeing slightly better shorts coming out. Slightly better over the upcoming. But yeah, there might be some bad ones. I mean, the recent shorts are pointless. Yeah, there's going to be some bad ones in the recent ones. But they'll get better. They'll get better over time. What function you're using for the neurons? Oh, function. This is we're using one library. This is the only library here. This is NumPy. We're using NumPy. And the neurons, which is the same as the parameters or the weights or the coefficients or the constants or the biases, the weights and biases, they're all the same thing. They're all the same. Is right here. This is it. It's a np.random. So I'll type that in the chat. Here we go. np or numpy.random.rand and then the dimensions. There we go. That's it. That's what the neurons look like. That's what the neurons look like. Really simple and straightforward. Well, I'm training your training translation model on a local language that is a spoken language. It is a low resource language. Okay. And try different training methods, but I am coming out short. Okay. So that's one of the challenges. You need to make sure that your algorithm is going to fit. One of the problems that I often run into is you need to make sure that your input data is all between 0 and 1. All right. So you need to make sure that all of your endpoint or between -1 and +1, right? So your input data, this is a common mistake. Input data must be between -1 and +1. You could add a normalization layer of some sort or what they call embedding. You can do some sort of embedding or vectorization. You need to be able to make sure that the data that you're feeding it, so like the language data, the tokens or the words or the letters, they all have to match this range here. It's a little forgiving. You can increase it. You can increase it to like -2 and positive, but you start hitting some problems. So it's better to stick it like that. It's better to keep the input data like that. And then your activations, and then you want to drop out or regression or normalization. There's a whole bunch of different things you could do. If you can give me 3 projects that would caught your attention, it would be really helpful. Okay, Drawing Brothers, anything with AI. Definitely anything with AI. Anything that would maybe have multiple computers communicate with each other and AI at the same time, or a game. Thank you for the likes. Or a game of some sort with like a game engine. That would be really cool. What AI are you using to create these shorts? The Quiz Club, it's my own. I created my own algorithm. It's my very own algorithm. It's actually really simple. You just use any model that has function calling or tool calling, and then you give it instructions, and then you feed it in the data that is associated with the video data itself, and then you have the model extract segments in terms of segments, and then it gives you deterministic output for which segments are the most interesting. And it does an okay job, but I need to keep making improvements on it. So it's just using an LLM and then function calling. And that's it. It's really simple. What do you mean by epoch? Okay, good question. Mancy, hey, if you're still here, sorry, I'm running behind on some of the chat. Epoch. Oh, someone already answered. Benedict. Thank you. Epoch. How many times the data is completed? So basically, say you have a spreadsheet. See, this is like our spreadsheet right here. And there's 4 rows in the spreadsheet. It would be training. 1 epoch is equivalent to training the model on the entire spreadsheet 1 time. 2 epochs would mean training the spreadsheet twice. 3 epochs, there we go. We're training the model with 3 times the data. Basically, it's how many times does the model see your data. And that's critical hyperparameter based on the learning rate as well. Because if you have a very low learning rate, you need to increase the epochs. But you don't want to have the learning rate too low, because then you'll have to have a lot of epochs and you're just wasting compute. So it's a nice balance, right? It's a balance, you guys. Converts the signal. Yes. How activation function works, such as sigmoid. Activation, I kind of call activations like a normalization between layers. It's a normalization which prevents numbers from growing too big, because you want to make sure to maintain all your numbers, right? You want to keep your numbers in AI. You want to always keep your numbers between -1 and +1. You just always want to sit. And so normalization, like for example, sigmoid and tanh. Sigmoid is 0 to 1, and tanh is -1 to +1. And so every time you activate, you're normalizing the output data, so that way the next time, the next layer will be able to capture the data, and it won't have crazy numbers. It won't have crazy numbers, you guys. So yeah, that's right. Benedict, you got it. It converts the signal from 0 to 1. I like to call it normalization. Okay, great. We'll try that. Excellent, Drawing Brothers. It's just a mathematical function. Yep, it is. You got it. Math. It's all math, you guys. If you skipped math, don't worry. It's not. Okay, here we go. Let's see if we can get it. All right, so we've got our first gradient, and now we need to. Oh, you know what? What we could do? A out, C out. We don't actually need. We could probably just do this. We can do mutation. We can do some mutation like this, and then B out, and then out like this, like that. And we do C out, just to keep things cleaner and simpler, so we understand things more simply. There we go. All right. I like simplification. If you didn't notice, I like keeping things as simple as possible. So this data right here is to calculate the error. I call it the delta. It's how wrong the model is. This is just to give us details on how the model is progressing. It's just a monitoring tool to calculate the cost, right? The cost or loss, if you're or slash cost of like basically how far off it is, how wrong it is. And so you use this information to print. You just print it. It's only for printing. You don't need it for anything else. But we do need the delta, because this is what the model trains on. It's like, okay, model, you gave us an output of, a number between 0 and 1. And the actual answer was 1, but you gave the wrong answer. And you were off by, half, like 0.5 or something. That's how wrong you were. And so we need to get that delta, so that way we can go back propagate and then update all the weights, so that way the model learns, right? The model learns, but you update it very sort of slowly. Hello, I want to learn some machine learning and deep learning to start SAS project. Now I learned NumPy, Pandas, SQL. Can you please give us some advice? Yes, for ya. For AI, for ya. You're not using CUDA, right? Correct. We're not using CUDA. This is all CPU, Benedict. You got it. This is all CPU. We're not using any hardware acceleration. We're keeping it simple right now. We're keeping things simple. So for it, we're doing that right now. We're learning some backpropagation, which is the hardest part. And we're using NumPy. JB, will you support multiple loss functions? Yeah, you could totally do that if you want. You can have as many loss functions as you want to sort of calculate, how far off you are from your objective. Because you want this number to approach 0. So good. So let's see this. Good loss equals below 0. Below 1, right? So you're going below 1 and you're approaching 0. This is a good loss, right? You want to approach 0. A bad loss is anything like above 1, and then increasing beyond 1, right? That would be bad. That would be very bad. If you want, you don't want it to see. You can, depending on your batch size and other calculations, because we're calculating the batch size. This number it could be bigger. It could be bigger or not. So what you really want to see in a good loss scenario is just a reduction, right? You want to see it learning. So you want the loss, which means how wrong the model is. The loss is just, how wrong is the model? How wrong is it? So during training process, you want to continue to reduce how wrong the model is. It's basically optimizing your backpropagating. That's what we want to do. We want to reduce the loss. So that's what we're doing right now. So we got the loss here. A good loss is not 0, right? You're approaching 0. Right. If you get to 0, then you've you've overfit, right? Thank you for the likes. Thank you. You want that loss is within a margin of error of your data, but not 0, since that indicates overfitting. It does. Yep. Because you can overfit, because you basically can get the model to always recognize perfection but then it will only really know the data, because the whole point of machine learning is to be able to make a very accurate prediction of what some sort of classification would be. Basically, you want to say you're going to train the model on a whole bunch of data, but you want it to be able to do a good job on data it's never seen before. On data it's never seen before. You want the model to do a really good job on data that it's never seen. And so if it's at 0, if you hit 0, that means that it won't generalize very well. It's like JB is describing. So you don't want it to hit 0 because that's overfitting. Depending on your model, but most likely it's overfitting. I apologize. Foria, I apologize for taking your time, but can you give me advice to learn machine learning? Should I start with math behind? I recommend not doing the hard part. We're doing the hard part right now. Okay. So if you want the simple approach, start with a framework. Do Keras, TensorFlow, Python. Here we go. I like how Google knows what like. Here you go. Do Keras, which is a high-level deep learning API written in Python, designed for ease of use and rapid prototyping. Start with Keras. Here we go. Start with Keras. Keras plus Python. That's what you want. That's the easy mode. We're doing hard mode right now. We are doing hard mode. See, this is what we have started with today. This is our GitHub repo of our code, which is very simple. This is the code right here. We're keeping things simple. Very simple. Okay, let's see how far we can get with the backpropagation. Right, JB sigmoides, for example, has 2 asymptotes. It has 2 asymptotes. What a cool word, asymptote. Yeah, that means, I guess, vanishing edges, right? Or two, I guess, because it's got one curve, right? So it's got between 0 and 1. So it goes, right, something like that. So it's got the top and bottom, and then it meets in the middle with this kind of like really cool S curve. That is the asymptote on either 0 and 1. That is cool. I like that word, asymptote. Do you come live every day? What time is really helpful? Oh, Mancy. Yes, live on the weekdays. Live every day on the weekday. Though Wednesday, Thursday, and Friday this week might be a little tricky because we might be going live around 10 a.m. Pacific and 1 p.m. Pacific is usually the range of time that I go live, because that's when I have the most free moments in the day. You guys, that's when I have the most free moments in the day. Zero loss means your model has nothing left to learn. JB, yeah. Oh, that's actually a really good point. That's also another good point. You've taught the model everything it could possibly ever know for its whole life. It has nothing left to learn from you. You taught it everything it could possibly ever know. That'll be actually really neat. The super AI in the future, when we have 100 trillion parameters, and we teach it all of humanity's information and resources, the loss could be 0 at that point, because it'll have nothing left to learn. It'll have nothing left to learn, you guys. That'll be so cool. Thank you for the likes. What about scikit-learn? Yes, that's also really good. It's a machine learning framework. It's easy. I recommend scikit-learn, but I recommend using it's kind of difficult to know where to start because there's so many cool things going on here. But I recommend using a support vector machine. Do scikit-learn SVM. SVM. Here we go. Scikit-learn SVM. This is what we want. Do support vector machine. I recommend doing this one. I'll paste this into our Discord chat as a good starting point. Because it helps you. It's more forgiving. But it's like stage 1 before you get to deep learning. Like, this is standard machine learning, support vector machine, and then you get to deep learning next. I think that's really cool. So that's a really good one. But I posted that in our Discord. Let's see here. Let's see if we can get back to this. Okay. See if we can. Vim, I believe. What is the programming you're programming called? Yes, you got it. You guys figured it out. You figured it out. Rana Joy, Vim. Yes, this is Vim. We are currently in Vim right here. This is Vim right here. We are using Vim, you guys. Using Vim. Sorry, I was a bit late. What data are you training on? Oh, sure. It's really we're doing a toy data set. So we're learning XOR operator, which is nonlinear operator, which is a really great I think like a proof of concept algorithm that you can use. That all the data sits right there in your app as well, and you don't have to call out to a spreadsheet. And it's a small amount of data, but it's a good amount of data because it can sort of prove that your AI model works. It proves that your AI model works. So that's the good part of the data. Thank you. Have a nice day. All right. Sounds good to me. Thank you so much. Please Google how to exit BIM before opening and using it. Yeah. You could have an issue there. You could have some issues using BIM. Yep. Principal component analysis. Wait, what does that mean? What is principal component analysis? I don't know. You're using terminology now. You're using terminology. Okay. Let's see if we can. All right. We need to do our backpropagation. Okay. So we've got our first gradient. Return gradient here. Let's just do this. Do we need, all right. So we've got our existing gradient. Then we've got our, wait, this is wrong. This is wrong right here. I know this is wrong. We need a reference. We need to go to our reference real quick. I like the simplicity. Yeah, that's what we're going for because this is the complexity and we're going for simplicity. So I'm going to try to simplify this because this is way too complicated, but it's also my reference. And it's using other things like this is using the output layer, but I'm going to be using inputs instead of the outputs when I'm calculating the optimization for the gradients. So what we need to do here in this, we need to calculate the gradients, but we could also just optimize at the same time. So I think we might be optimizing. We'll see gradient. We'll probably be optimizing layer.weights. Then we have the gradient. Gradient. Here we go. Gradient. And then let's see here. So we need to multiply by the learning rate. We did that. We did that. We could plus equals probably. Oops, nope. Plus equals. We'll try plus equals first. We might need to do minus equals. We'll have to come back to that. I don't remember. The simplicity might make it one way or the other. It really depends. But we'll see. Okay, so we got our gradient. And then we need, okay, let's figure this out. All right, so we got our first gradient. Then we need to calculate the second gradient. Let me just copy and paste this into here. Let's go back here. Hold on. Function F2. Go over here. Thank you for the likes, you guys. All right. So this is what we need to simplify. We need to simplify this. Here we go. Like this. But let's see. What is the next gradient? Okay. So the gradient is going to be, here we go. We need it to, okay. So the delta is going to be gradient in our case. Okay. Deep learning. MK Gamer, how's it going, MK Gamer? Deep learning need big data set. It doesn't always. In fact, check this out. This is not a big data set, but we are doing deep learning. But it's not a big data set. I mean, it is 100% of the data. So you can, from that perspective, but this is a deep learning model. We're doing backpropagation with deep learning, and the data set's small, so it can be. But you do, yes, you're right, MK Gamer. You do bring a really good point. You do need a lot of data in order to get a good generalization, especially with deep learning. It demands more data than a standard machine learning model. With deep learning, you need even more data. So you're right. You're totally right. But it's not mandatory. You can still get something to work with a small amount of data. Can you do a one image training? Yeah, you could if you wanted to. What are you doing, JB? What are you doing? Are you using a CNN model? Today we're doing just a regular ANN. So this is an ANN. This is our, artificial neural network, if I can spell that right. That's what we're doing. That's what this is. So which means that we don't have any filters, and it's not a transformer, so we don't have any QKV, query key and value. So it's or we don't have any remembrance with a recurrent neural network. So it's just basic. We're doing just the basic. We want to keep things simple. We're keeping things simple, you guys. Data is always the problem, especially for like cancer detection. Yes, it is. I remember they trained a model on cancer detection, and then it found anything with a ruler in it that was measuring the mass or whatever, the cancer mass, it said was cancerous. So if there was ever a ruler in the picture, so you have to be very careful with your training data set. You have to be very careful because you can cause issues. Okay. I think this code will actually run, but I need to double check that we are going good here. So something else to keep things simple. I don't necessarily need to be passing in the, well, yeah, I do. Okay. Yes, I'm going to keep it like this. We're doing good here. What projects would you be like to do with Python in Blender? Ooh, with Blender. Freckles Artie. What projects would you like to do with Python in Blender? I don't know. I'm not sure. Maybe, I really don't know, because Blender's, for 3D modeling, right? To create 100 vectors. I don't know. I really don't know. What would you do? That's actually, because you don't necessarily want to write a game, right? Or a game in Python because it's kind of a slow language. But you might, because Python is such a simple language, you might want to try that. So, some sort of game where you output your UVs, right? Your texture values. And then maybe your normal map as well. And so you can have really cool lighting on your 3D model. You could do things like that, Freckles, in Python. You could. Melody of Draco. How's it going, Melody? Is this an open source data or custom scripting? Also, is it on cloud or local hosting? This is local. We're on local. Melody, we're on local. And this is open source. I put it on here. So this is our repository. This is our file. I'll put it on our Discord just to remember. This is the file that we're currently working with. It's open source, you guys. I created a model for image classification, real image or fake. Ooh, you did, MK Gamer. That's really cool. Is it a fake image from an AI or is it a real image? And the model name is Efficient NB3. Nice. Yeah, you totally could, because these AIs, when they're making images and things like that, they have a different signature from like pixel blooming perspective. I remember looking at some a YouTube video that was describing how to detect a fake image from a real image. And based on how pixels are oriented with each other, especially with lighting and things like that, and how, what is it called? Diffusion models, right? They diffuse from random noise into an image that creates different patterns with the pixels that you can easily detect with a machine learning model. You guys, you can detect the fake AI images pretty easily. Recently, I've been thinking of simulating certain real-life events to prepare, such for wildfire simulations, or for hot shot firefighters, or simulating the cleanup of certain types of forever waste. Ooh, Freckles, this sounds valuable. Now you're talking industry, aren't you? This is really cool. Thank you for the likes, you guys. You can write tools for Blender and Python. Oh, you can. Oh, JB, I didn't know that. So that's actually a really cool idea. So then you can create something, maybe merge in like an AI that can use Python to describe what, I don't know. I'm just like coming up I'm randomizing it. I'm not sure, but I have very little experience with Python. Recently, Cyblend will come out, which adds more scientific data simulation in Blender. Does it? Okay, so that sounds really cool. Okay, so now you can use Blender as the visualization tool. Now you can use Blender. What you should do, Freckles, look at this. Okay, check this out. This would be really neat. This is what I'd love to see. See right here, we have got 3 layers. They're all meshes, right? They're all 2-dimensional meshes. You can visualize this mesh in Blender. You can visualize this mesh right here in Blender. Right here in Blender, you guys. Wouldn't that be cool? You could visualize an artificial neural network in Blender using the Cyblend. You could do that. That would be so cool to see. And then you can, based on the values of the vectors, right, of the XY coordinates, you could show some pretty colors, right? So if the model looks like it's creating a cone that's too big, you can like make it red or purple or something. But then if it's down low, then like make it cool, like blue or green. That would be really cool. You could do that right here. So you could do that. That would be sweet. That would be wonderful. That would be so wonderful. But I have very little experience with Python. Oh, right. I already read that one. How do you do AutoGrad engine? AutoGrad engine. I think this is like, sounds like AutoML, right? Doesn't it sound cool, Freckles? That would be so cool. AutoGrad, I'm not sure. I've never used it, but it sounds sort of similar to AutoML, where you have a machine learning model that is able to tune its own hyperparameters by trying out. Dig that enthusiasm. There you go. Thank you. Thank you, Ama. Thank you, Amaya. Thank you so much. we got some enthusiasm here, you guys. MK Gamer, now I want to create video classification, real video and AI video using deep learning. You totally could, MK Gamer. You totally could. You could totally do that. You could classify it and find real video versus fake video, you guys. You could totally do it. Benedict, visualize ChatGPT. You need the Vegas sphere to display it. Yeah, because there's so many models, or I mean, so many parameters, you guys. It would be so much data to visualize. It's just like would be way too much. But you could simplify it. You could probably simplify it a bit. Have you written GUI plugins before? That's actually, I've not written any GUI plugins myself, but has anyone in chat written any GUI plugins? I'm wondering. All right, let's see here. Let's actually get back to our backpropagation. All right, let's see if we can make it happen. Okay. So I need to, this would be gradient, right? So delta is the gradient. So we got our gradient, and then we need to reapply. We need to return this value. This is what we need to return. So the new gradient, so delta, which will be gradient, we need to do a dot on this. So we got our first gradient here. Okay, so dot, let's just here's what we'll do. We'll just copy and paste this line here, and then we'll write it so that way it's our own gradient. Here we go. How can I be perfect in machine learning? Luca, how can you be perfect in machine learning? It's a lot of practice, and guess what? You still never be perfect, because I've been practicing for a decade and a half, and I'm still like, what? How do you make it work? And it's so difficult because you can be you can have imprecision. You can have imprecision in your model, and it will still work. You guys, it'll still work. You can have it's very forgiving. It's very forgiving if you get it to work. All right, so let's see here. Gradient. Let's see gradient, and then we self dot weights like this. Self dot weights dot transpose. We gotta have that transposition in there. Self dot active derivative, and then we need self dot input. We're not doing outputs, we're doing inputs. Self dot input. There we go. I think that'll do it. I'm not sure. No, we're gonna try. Hey, Quantified Quantum, how's it going, y'all? You're late to the stream. No worries, got busy. We only wrote like 3 lines of code, so we've just been talking to chat, you guys. It was moving state logic using Zoostand instead of my own solution. Oh, there you go. I mean, it's good. Hey, July Ort, how's it going? Welcome on in. That sounds like a good project, Quantified Quantum. You're simplifying. You're making things better. And that's what we're doing here, because we're turning all this code here, which is quite a lot of code. I mean, if you just look at all this code. It's just so much code. And we're going to make it simple. We're going to simplify it. So I think we did it. I think we got it. Especially if there's some communities already struggling with water vulnerability. So Freckles, yeah, I missed your chat there. Not always a fan of AI, especially when the data centers infiltrate communities that already are struggling with water availability, because data centers, they take up water. They consume water because they need to keep things cold. July Ort, how's it going, July? Happy to have you in here. Melody of Draco, do you use AMD GPU or NVIDIA? I know AMD is an open source GPU that doesn't require restrictions, and C++ is better for the graphics engines. Yes. Can you use C++ instead of Python? Yes, you can. You can use C++ instead of Python. So what we're doing here is we're using Python for simplicity. But you'll want to use a library that implements C below it. So if you want to maintain the simplicity of Python but get the performance of C++, you can use something called PyTorch. And PyTorch is written in C++, but it has bindings to Python that allows you to interact with it within the Python language, so you get the performance of C++, and you get the performance of accelerated hardware with your GPU. So PyTorch is a really good option. I think PyTorch is a really good option there. PyTorch is a really good option. I'm looking for job help from your viewers or you. Oh yeah, Luca. Okay, so we do have some open roles on our website here. So let's do PubNub careers. I know we've posted that jobs at PubNub. Here we go. So we've got AI engineer, SRE, and we've got a solution architect. We've got 3 technical roles. I'll paste that into our Discord channel. Here we go. Three roles here. We got 3 roles open for you guys. Look, there are no one solution. Just the constant struggle for improvement. You got it. Mohammed, you're totally right. Just constantly improving. Never perfection, always improving. Just making it better every day, a little bit better every day. Just the constant struggle for improvement. Like he said, it's forgiving, and even a 1% increase in accuracy can garner large gains when it is on a large scale. You're totally right. You're totally right. I'm good. Did you move to binary cross entropy, or is it the MSE? That's right. So in our Discord, let's see if I can scroll back. Last week, there was a recommendation that I'm looking here. I don't know if we'll see it here. Here it is. Here it is. That talked about using cross entropy instead of MSE. We haven't yet. We also haven't moved to sigmoid for the output layer. So there's a couple of recommendations in here that we haven't made adjustments for because we're just trying to get the backpropagation working. Once we get that and everything's stable, then we'll make the optimizations and we can do some cooler things. And we'll like get the binary cross entropy right here. Binary cross entropy is better. So we can make some adjustments like that. For now, we're just keeping things real simple. Real simple, you guys. But that'll be the plan. Python is just easy and read. He has libraries that bring it close to C++. C. There you go, Benedict. There you go. PyTorch. There you go. LibTorch. That's it. That's what the answer is. Rana, hey, how's it going, Rana? Are you know the real world problem that or anything you want to solve, please share with me. I am very happy to work with you. Right now, at least what we're working with is not a real world problem, but sort of a proof of concept problem that it proves that your model is working. So that's what we're trying to do right now. So we've got some toy data, but once this works, then we can start trying other kinds of data, and you can almost do anything. And then you can upgrade your model to support like a transformer model. So you can have like, you can keep data. You can basically, temporal type data or relationship or like full self-attention. We can do a whole bunch of really cool things. But we're starting with the basics right now is what we're doing. Starting with the basics. Run make an AI to hide my money from the IRS. There you go. Make an AI that, there you go. It's called, what do you call that? Laundering. You want to launder. You want to do laundering is what's happening here. July, good. I want to see that. Cool. July, we'll make it happen. But first we got to start with actually getting it to work. So we've got our gradients here. We got our gradient. I'm pretty sure we got it. So this is wrong. This is right. So this is our gradient. So I think we could say self.gradient here like this. We can return that. I think that is good. I think that's good. So we've done the backpropagation, and then we need to do the optimization next. I think maybe, maybe, or wait. No, we have to do. We can't do it like this. I think we have to do it like this. Like this. Here we go. Like this. I think we have to do it like that. Gradient. We could be right. I think we have to do it like this. So this will allow us to do optimization separate. We got to get things in the right order, you guys. You got to get things in the order. Dang, using ZooStand React State Solution saved me 30 lines each module. That is amazing. That is an amazing amount of code reduction. What you just did there, quantified quantum, is called code reduction. And it is the best kind of engineering ever. It is the top. If you have a pull request and it has a whole bunch of negative lines reductions, that is a really productive day. You just did a really productive day. Melody of Draco. Melody, what are your thoughts about Microsoft Quantum CPU they made? Do you favor cloud hosting AI or locally hosting? So that's a lot of questions. The quantum CPU that they made, the QPU, and Microsoft had some sort of I don't know the details about it, but I've heard about it. I've heard about the Microsoft quantum processor. It's still all theoretical. right? So there's still all the existing quantum processors are theoretical proofs that they're probably on the right direction, but they're not so valuable right now to actually help solve real world optimization problems. And so what we need to do is get this scale. We need a whole bunch of quantum bits to be able to calculate some of the world's hardest quantum optimization problems. And then once we get there, then we are getting closer to validating the architecture of the quantum processors. And the architecture in a CPU world is what kind of physical qubit is it? Like, are we talking about photons or electrons, or what is it made of? What is the architecture? And then how to maintain coherence, right? So there's a lot to consider, and we're nowhere near. So Microsoft, they can make claims, but really no one really can do a whole lot with existing quantum processors. Local hosting, though, for sensitive data, there you go, Benedict. And then everything else on large-scale cloud hosting systems. You got it. That's pretty exactly like Benedict described. That is the answer. Finally, I'm graduating, guys. You are, Luca. Congratulations. If you're graduating, if you're actually graduating, that sounds really cool. If you're graduating from, school, great. If you're graduating from understanding into a new level of understanding, that's also a good thing. So each layer will have two gradients chained. So we're gonna have. We forgot the bias. We need to do the bias, you guys. We forgot the bias. We have to wait. No, we don't have to worry about that. I don't think the bias. I don't think we have to worry about that here. I think we have to do the bias and the weights here. I think we do bias and weights down here. So we do something like this. Later. Okay. So the optimize actually looks pretty good. So let's do self.bias. But we need to figure out it's going to be different. I need to go to the reference, you guys. From university in Kenya. Very cool, Luca. Congratulations. That is a huge step forward. That is amazing. Quantum computing are just like throwing airplanes into the void, hoping it hits something. It is. You're totally right. You're totally right. That's exactly what the existing quantum processors are. But we're trying to create coherence across a lot of quantum bits. And if you do that, I call it like sort of shining a light through the system, and then you sort of beam a light, and it creates all of these interference patterns based on its entanglement, and the final output is like the shadow. But all these bits, they're like shooting off all sorts of different directions, and there's all this noise coming out from other systems. And so in order to see if it actually works, what they do, because they can't maintain coherence for very long, or one of the runs might fail, they run it multiple times. They run it a whole bunch of times. I call it like turning a light bulb on and off. So like taking a flashlight, turning the flashlight on and off, and then flashing it at like a wall with a whole bunch of lattices. And then the result is the shadow. It's the shadow at the other end, like on a back wall. And that is the result. That's kind of how I think about it. That's like a good way to like sort of visualize the concept of quantum computing. Is we try to configure all of these lattices, which are the quantum bits, and how they're entangled and relating to each other, and then you can apply coefficients across them to change the amplitudes, and so you get this lattice that's really interesting shaped lattice, and then you can shine a light bulb through it, and the light bulb will hit the back wall. And then the result is the shadow. That's the answer. That's how I like to think of quantum computers. I could be completely wrong, but I feel like that's a really good like general purpose, like a visualization of how quantum computers work. Do you think the Menendez will control the U.S. and Chinese drone networks using quantum computing chips? No, Con4, we can do that already. We don't need quantum chips for that. We already got AI and regular chips to do that. We're good to go. We don't need to worry about that. John Darland, how's it going? What are one thing about life that coding has taught you? Genuine question. That's actually a really good question. It taught me that I like doing it. It taught me that it's really hard. It's really hard because we're struggling right now. We're struggling and we're trying to make it work. And we've got a finite amount of time in our life to feel to understand if we can make it work. But guess what? Here's the thing. When you get it to work, it's very satisfying. It's very satisfying. But also, I think probably the best thing that you could do here, actually, I have your question, John. I found it. John Darland, if you're still here, I've got your answer. Are you ready? You can, so if you're looking to start a business, go into software, go into AI, anything like that, because you can replicate it and scale it really far because it's really easy. Considering like traditional business that's brick and mortar where you have to sell inventory, you have to acquire inventory. You can either do that by, like you farm it, and then you have to construct it, and then you have to bottle it or whatever, and you have to package it. There's a lot of logistics and cost up front. But with software, you can scale it nearly infinitely. Almost infinitely. So it's a linear scale and it's really easy. And it's a lot more straightforward to have a software industry business than it is for straightforward in a way for scaling perspective, but not straightforward from understanding what to actually build. But if you can, and you have the opportunity and you can have a business in software, that is the cool part, is it scales. And that's what's exciting. That's what's exciting about programming, and that's what coding has taught me in life. Connect me to your job in your country. Luca, you got it. I pasted here on our Discord channel. There we go. Jump to the present. Links to our job board. So here on our Discord channel, you guys, that might help. I like to take a snapshot. Wait. I'd say like taking a snapshot. Wait. What do you mean taking a snapshot? Wait, quantified quantum. Did I miss something? Oh, it is like taking a snapshot. You're totally right. It's like taking a picture. It is. It's exactly like that. You got it. Quantified quantum. Can you donate an old computer for me so that I train daily on ML just like you kindly please? Luca, so what I do, so we're doing it on just a regular, you can do this on a Pentium 2. Like a really old computer can perfectly run this. Because it's very small. It's only a few thousand parameters, but it will demonstrate to you how to build a machine learning model. So that's what we're doing here. We're almost there. I think we almost got it. We need just a few more things, and then we're good to go. We just need a few more things, you guys, and we're good to go. But yeah, it'll work on any computer. Like machine learning and deep learning, you don't need a very fast computer to get it to work until you get to production grade high scale systems. But then even then you can rent a computer from a server for like 10 cents per hour, something like that, or even 4 cents per hour. You can rent a very cheap computer on the internet, like a cloud computer, to do some of the heavy lifting work for you. You could do that. That'll work. Coding taught me that there is to make programs that generate code for me. Yeah. You can just have the computer do the coding for you. There you go. Benedict, you figured it out. Bro has live subtitles. You got it. Dalen, how's it going, Dalen? We have live subtitles here, Dalen. There you go. Dalen. Chitu. Hi, how's it going, Chitu Royal? Welcome on in. Luca, I don't have a computer, brother. I'm using a phone right now. You can do it on your phone. You could do it here too. You just need Python, and then you could get like a Bluetooth keyboard. You could get a Bluetooth keyboard, and then all of it on your phone. You could do 100% of this on your phone. You don't need a computer. Quantum for quantum, I'd say, Steven, one of the biggest flexes is live captions. Yeah, because I wrote this software right here, these live captions. I wrote this 7 years ago. I actually made it work 7 years ago. That would be that's the flex. You got it. Potato programming, bro. You will lose jobs to AI in future. So here's the deal. The kind of coding that we're doing right now, where we're coding by hand, yes. Writing code, all right, everyone, check this out. Writing code is no longer a job. Engineering is still a job. We still need engineers. You still need engineers. We won't necessarily be writing code because the AI will do that for us, but we still need to read the code, understand the code, and have a general idea of what the code should be. So we still, as an engineer, need to understand the code. And that job is still very active. and it actually is growing. We're going to see an increase in the demand for engineers, software writers who write the code. Those jobs are gone. Those jobs are out the door. They're basically disappearing right now. No one is going to be writing code anymore. It's gone, you guys. There's no more code writers because the AI writes it for you. But engineering is still a thing. You still need to know how to work with the AI to write the code in a big, giant paintbrush style rather than individual keystrokes. That's it. Luca, you can use a phone SSH client to get into a machine. So you can AAA. That's a good idea. Potato loose. Yep. Jobs. Yep. You got to be careful. Careful about those jobs. I think coding is a skill that is underrated. Yeah. Melody. It is. And that's what we're trying to do right now. We've got all the AIs turned off. All the AIs are turned off. Dalen, interesting, isn't it? Should be possible on an Arduino too. Benedict, you got it. You can a Raspberry Pi, even like an RPi. That are really, because I think RPis, you can get really inexpensive RPis, but if you have a phone, you could get a text editor on your phone and a Bluetooth keyboard and maybe even a Python interpreter, and then you can do that there as well. So you could totally do that. Can cybersecurity dudes lose jobs in future? Potato. So cybersecurity is actually probably a role that's going to be more heavily dependent on humans, and humans writing software to detect infiltration. So Potato, I think cybersecurity is a good discipline to invest your time in for a future career. Time to vanish, closing in on my screen limit. Okay, Quantified Quantum, thank you for hanging out. We're going to try to get this backpropagation to work. Give me your number or an email. We can communicate. Luca, just join our Discord. Join our Discord here. I'll paste it into our chat. We'll copy paste that over here into chat. There we go. Join the Discord, and then we can chat here on our Discord. And it's a good next step. You guys. Would you prefer to learn tools using a career like DevOps or a true programming where you can understand and custom a script? You're basically a craftsman. So DevOps is a huge industry all in its own, but you're going to still need to be able to leverage these AIs to write custom tools or different programs to operate your day-to-day. So the roles are blurring. You guys. You could even go into an online Python compiler. Oh, you could. Benedict, that's a good idea. Oh, you're so smart, Benedict. Oh, I didn't even think of that. Okay, so Python online compiler. Here we go. You could do that. And then go here, and then boom, there you go. And you click run. Look, right there, we printed. There, check it out. Code execution successful. Wait, it's supposed to print. Yep, here we go. So you print hello world. So zoom in, check this out. Right here, check this out. You can just go to this website, programmings, and then type in hello world, exclamation point, and click run. There you go. Output, hello world. See, you can do it right from your online, right from your phone. There's no need for a computer. You guys. Okay. That's a really smart idea. Benedict, thank you. What would be the best area in programming for freelance in AI era? Not corporate job. Leaf Gang, how's it going, Leaf Gang? So what would be the best area in programming for freelance in AI? Probably here. I've got your answer, but it's basically automating workflow processes. You want to be able to automate workflow processes. So, hey, Steven, how are you? We're doing good. Welcome on in, Syrian, Sir Yan. I was trying to pronounce your name from previous streams. We're doing really good. We're doing backpropagation today. We're doing backpropagation on our machine learning framework that we're simplifying. I think we mostly got it, but I need to check the reference code. Mr. Lamb, how's it going? Oh, I was up all night this past summer in this website. Learned up to coding a functional calculator. Very nice, Mr. Lamb. That's a really good a way to train is to learn by creating an application such as a calculator. That's a really good application. So in order to learn something, you need to build something with the tool. So that's like the best way to learn the tool, like a programming language like Python. What you want to do is to use the tool. And to use the tool, you want to build something and build something like a calculator or a to-do list app. So those are two very common, really simple applications to build to leverage the tool. And it helps you learn. It helps you learn a lot. In school, I learned Python, like functions, stacks, stuff, and SQL databases also. But how is this even used in future? Potato. All of that's used in the future. Those kinds of things are used day to day in business and industry. So I use SQL almost every single day to do data analysis. And then I use Python to write code, mostly these days to merge with an AI that's doing tool calling or function calling to get deterministic output from a large language model to do certain tasks for me automatically, such as previously mentioned in chat. In chat a little bit previously was talking about my shorts, my YouTube shorts are taking this video here, and they're processed by a Python script that calls an AI to sort of figure out which shorts are going to be the most useful. And so there's a whole bunch of patterns that you can use to automate using that approach. So that's my favorite. But yes, it is used in the future. It's used every day. I can prove it because, at least I can tell you, if you believe me or not, that I use it every day. So it's absolutely worthwhile. Okay, so we got our inputs. We got our bias and activation through a forward. We're saving the gradient. We got our gradient here. And then we're going to use it for training. So we don't need that. We don't need this. We just need optimize. So we self.gradient times learning weight bias. And so we need to finish this part here, I think. We need to finish that. But we also, I think we're good because this returns the next gradient. So I think we're good there, you guys. Yeah, I did it if I had to put it up in my resume for uni next year, although not sure how far it would help in a commerce degree. Mr. Lamb, absolutely. Thank you for the likes, you guys. Thanks so much. I see the little heart icons showing up there on the screen. You can see the heart icons right here. Thank you for the likes. You're totally right. Although not sure about how far. It's worth it. It's totally worth it. It's absolutely worth it. And thank you for the likes. It's totally worth it. Python. You got it, Python Cyber Potato. Python. What are you doing physics? Oh, that's a good question. Physics is also fun because there's a lot of math that goes on there in the real world math application. Thank you for the likes, you guys. Everett Rivera. Everett, how's it going? I stink at coding. What is the easiest way to get better? To build a project. The easiest way to get better is to build a project. Like a calculator, use Python to write a calculator app or to do app. And that's the best way to get better is to build something. It's a tool. The programming language is a tool. Thank you for the likes, you guys. It's a tool. So you just need to use the tool. And to use the tool, you will. You have so many likes here. You can see them show up. I appreciate it. May I ask what you're programming? Oh, Shin. Yes, absolutely. We are building a deep learning framework. And yes, on Friday, we built the forward pass, which was the easy part. Now we're doing the hard part, which is the back pass, the backpropagation, to do the actual learning of the model. The part where the model learns, the learning part of the model. And that's what we're building today, the backpropagation. Mr. Lamb, I would suggest practicing more, maybe attending free paid courses. At Mr. Rivera. Yes. That also helps. So there's a whole bunch of ways to learn. You can watch YouTube videos. You can attend courses online. You could try building stuff yourself from scratch. You can read documentation. There's a whole bunch of different things. Going on there. Okay. Let's see if we can finish this. Because I think I have an hour. Let me double check my time. I think I have 1 hour left. Less than an hour, but I think we can make it. Yes, I have less than an hour. Okay. We could probably make it, you guys. So we've got our forward pass done. We got our backward pass. Now let's double check here. Okay, so bias. Let me double check. Let me go here. Okay. So I only need it there. So we got that part. We almost got that part. We almost got it. So delta, copy. All right, so I need to make these adjustments here. This is the one thing I'm missing. I need to make this. All right, function F2. Let's go back. Okay, so our optimization function is not correct. Our optimization function needs this here. Here we go. Like that. We need to figure out how to we need to translate the simplicity into this. So I need to take this and then convert it into our custom framework. Julia language and Scala or Scale. Do you use these? Scala or Scale? Julia. No. So I use Bash, Python, JavaScript, SQL, Rust, C, and then everything else. But Golang, those are the premier business languages. But we don't in industry. In the market, we don't use Julia, we don't use Scale, but we do use Bash and we do use Lua. Those are languages that are definitely used in industry. But there are academic languages that kind of help train you. But I like Python because it's an easy language to learn. Python, an easy language to learn, and it's an widely used industry language, and we use it all the time. So if you want simplicity, it's better, and you want to learn quickly, just learn Python. You don't need an academic language like Julia or Scale or Basic. You don't need that. But that's how some professors teach, because they don't live in the industry anymore. They're outside of industry, so you're gonna get stuck learning some of the old stuff. You guys, you got to be careful. Sounds cool. I did a project on Hopefield Net using Fortran. Oh my God, Fortran! What are you doing, Fortran? But it was really messy. I guess Python would be much easier. It is, yes. So there's COBOL and Fortran and these older languages. We don't need to use them anymore. We can use Python for simplicity, maybe even JavaScript. There you go. Keep things simple and clean. Hey, Falloid, I procrastinate learning Python every day. Don't worry. Just in order to get better at something, a little bit better every day, just do a little bit. Just do a little bit, maybe 5 minutes. 5 minutes is better than 0 minutes, because 0 minutes is failure, but 5 minutes is progress. Do something, just a little bit of something. Even 5 minutes is worth it. Cyber Potato, do you believe learning formal logic helps you in programming? Not really. No, I mean, there's one case where it does, but it never otherwise. Is when you're using if statements and logic gates. But rarely do you do that. Take a look at this code here on the screen. Let's take a look at this code. Do you see any if statements in anywhere in this code? Is there one logic gate program anywhere in this code? Nope. You don't see a single if statement. Look at this, you guys. There's not a single if statement, not a single and, not a single or operator in this entire file, because they're just not that common. And so learning logic, like the logic in college or in a academic setting, isn't necessary to learn programming. In fact, I did take the logic course in college, but I learned programming 20 years before that. Well, not 20, like 10 years. 10 years before that. I learned it 10 years before that. Not 20 years. What am I talking about? Keep me honest, you guys. Got to keep me honest. So you don't need logic. Sir, Mr. Lamb, I would like to raise a query. Can Python be used to mine crypto through blockchain series and maybe like blend it into local UK traffic? What are you doing? What are you doing? You could use GPU acceleration frameworks in Python to look for a hash, or I guess a salt that will hash the current block to find a match. Because that's what you're doing. In order to mine, like in traditional consensus algorithms like the Bitcoin blockchain, you're creating a random number that will match the desired number of zeros in a hash which is a hard problem to solve. But you need to basically create a random number and then compare it to match a certain hash based on the inputs of the current chain of transactions, current block of transactions. And so you need to do heavily parallelized compute to be able to capture a potential match against the number of zeros in that hash. And so it's a very hard problem to find. So you need to create a lot of random numbers and a lot of hash computations. So maybe is the answer? I don't know. Wait, Julia is a 2012 born language made from solving the two language problem. July Ort, I don't know. So see, here's the deal. I've never programmed in Julia. I've completely bypassed Julia. I've never used it. So at least I can tell you from my experience that I got by with just fine without learning Julia. The D language can help with C++ memory garbage management. That's what ChatGPT says. Melody of Draco. You're right. D was supposed to be the successor to C. For whatever reason, we're still using C. I don't know why. D. We just stopped at C. We're like A, B, C, done. We'll try D. Nope. Back to C. Back to C, you guys. Will, do you believe that Kevin Gates started the car battery with his bare hands? I don't know what that means, and I don't know this. Will, I have no idea. Steve, hey, we've got a similar name, Steve. Is it common for coders using AI? Yes. So going forward in the future, right now, today, coding is done. We're done writing code. AIs are writing code. I mean, I'm doing it by hand myself right now because we're doing hard mode. We're doing hard mode, you guys. But you're right, coding is done. But engineering is not done. So yes, Steve, is it common for coders using AI? Wait, I think you mean coders using AI to write code is what I think you mean. But yes, Cyber Potato, some people say that coding is just a higher order logic. To what extent is this the case? Coding is just higher order logic. It's an abstraction, mostly a series of steps that are needed to calculate an outcome. So technically, yes. Technically, it is. Thank you, Shin. Thank you, Stephen. Your explanations are crystalline clear. Subscribed. Thank you, Shin. Appreciate it. Wait, Mr. Lamb, wait. What is this? Bro is actually answering on borderline illegal stuff. Am I? I mean, I'll tell you my knowledge based on what I understand is possible. If that's the case, can Python be used to leak the unredacted version of Roswell crash report? Well, you could, but you need the data. There's no way that you can just manifest it. You can't just manifest the Roswell crash report. You need at least some sort of fragments of information. And then if you have that, you can piece together the rest of it. It's like solving a puzzle. If you get like a few letters, right? You get a couple of letters in an unsolved equation, you can then so you need a few letters first, and then you can do it. You totally could, Mr. Lamb, you could. I don't trust any online source that offers a course, which is why I put it off. Okay, yeah. So, Foolati, just use YouTube. Use YouTube, watch YouTube, and then just search for YouTube tutorials. It's free. It's completely free on YouTube. It's how I learned. It's completely free, and then you can just move forward from there. I think it's a good place to start. Tommy Gunner, what's up, Tommy Gunner? What do you think about cybersecurity risks with AI writing code? That's the new task of today, is to leverage AI that writes code for you, but then also leverage AI that can audit the code for security vulnerabilities, right? You see what we did there? We're engineering now. We're engineering. So you need to be able to leverage these AIs and create your own AI agents to validate any potential holes. Also, you should probably know how to verify them yourself too, right? You should probably know how to validate them yourself as well. So good not trusting. Cyber Potato, why is foundational pure maths taught in computer science courses like proofs, functions, relations, and set theory? Because it's kind of what programming is. So calculus is like a precursor, is actually what software is based on calculus. It's a whole bunch of for loops, conditionals, and boundaries and borders and things like that. You don't need it, right? Because I learned before the math, I learned software engineering first before the math, and then I learned the math after. I'm like, hey, this is exactly like coding. I didn't know that math could be like this. This is really neat. Because you can go from either direction, doesn't really matter. And you never need to learn math. You just only have to learn coding. There you go. What do you think of C++? Oh, Rust. We're migrating all of our code to Rust. So that just lets you know right there what I think of Rust. So we're migrating all of our C and our Python, our Go code, our JVM code. Everything's migrating to Rust. We're moving all of our code to Rust. Set theory and relations is like important in every aspect of internet functioning. It is. I think it's useful. It's useful for sure because it can kind of like, I didn't understand sets or lists very well when I was introducing myself to computer science. And it took me a while to figure it out. Maybe if there was a foundation of knowledge with set theory, I might have had a better time learning computer science and software engineering. I mean, probably, yeah, it would have been easier, but it's not required because I'm proof. I didn't need it. Hola, how's it going, Simmer? Same RXN. How's it going? Hola. I prefer reading. What do you think about W3 Schools? W3 Schools is also really good. It's also really good. It's free. It's free, and it helps a lot. Neither am I. Brav, the only calculus we are accustomed is the definite integration and integration and derivatives. Yep, there you go. There you go. I like applying it. I like applying it directly. Okay, let's see. We only have. All right, so I want to give it 30 more minutes. We've got 30 more minutes and we have to finish this. I have no coding. I have no background in anything you're talking about. Can I still learn? Yes. Ghost cat, you can. Ghost cat, you can totally learn because that's how I learned. I had no background. I was like 11. I was young. My brain wasn't fully developed, so I didn't have a lot of coping mechanisms, but I was still able to learn computer science and software engineering. So you don't need to have any background. You can just learn it straight. Thank you for the likes, you guys. And if you're older, you can learn things a little bit more easily, I'd say, because you've got a foundation or things to sort of lean on. Thank you for the likes, you guys. AI inspection, AI code is like marking your own homework. It is. It is totally like that. And that's what we got to do. We got to engineer our ways out into this situation. Okay, I got to make this work. Okay, so we've got our bias. So we've got our weights. So wait, hold on. What did I call them? I call them bias and weights. So I have bias and weights, but these are biases. I wonder if I'm just going to call it bias. All right, let's. What we're going to do is we're going to copy and paste this here. So we go like this. So we're going to do optimize. There we go. And when we don't need this, we just need this, weights, and then biases like that, plus equals. And we have a learning rate, or we called it learn rate here. All right, learn rate. All right, we're gonna make this. We have to speed run this, you guys. We got to speed. And when we do out inputs, so wait. Do we need? There we go. Gotta type things correctly. Awesome. Computers can't integrate, so they have to try out regression. That's basically it. We're regression. That's all they have going for them. That's it. That code 4. You'll this code 4. We're creating a from scratch a machine learning framework or deep learning framework. And we're doing part 2 today, which is backpropagation, which is the part where the AI learns. It learns. This is how it figures things out. It learns. And it's the hardest part. It's the hardest part of the algorithm. And so that's what we're doing today. That's what we're doing today, you guys. So I need to, all right, so this is the gradient, self.gradient. There we go. Self.gradient here. Axis 0 output. So this self.outputs.transpose. This is the part I'm not sure about. I need to figure out this part right here. I don't know what's going on here. So that arrow. There we go. And then we need to double check this. There we go. This is the part I'm not sure about. We got to figure that out. If you don't mind me prying, what do you exactly do, sir? Okay, I've got your answer. Here we go. This is on LinkedIn, so you can see me on LinkedIn here. I don't know what I do. I have a company, and I help the team be successful as best as I possibly can. That's what I do. I have a company, and I try to make the team successful. That's what I do. And I'm on YouTube right now. We're live streaming how to do machine learning. That's what I do. How about safety mechanisms? Thank you for the likes, you guys. What about safety mechanisms? So that is another thing. You need to be able to capture all possible error conditions and when you're coding in general, that's like one of your main jobs is to take care of safety. So you also need to be able to read the code from that perspective. You just need to be able to read the code. Melody, I was coding stable like 8 years back stable, or now, like I feel there are many bugs and does have a compile like Eclipse better, or is VS Code, etc. is matter? It doesn't matter because I use Vim for everything. And it doesn't matter what your editor is. Use the editor that makes you happy. Use the editor that makes you feel happy. It doesn't need to be the editor that makes you the most productive. It needs to be the editor that makes you happiest. That's the editor. That's the tools that you should use, because we don't spend a lot of time actually typing code. Even before code generators existed, we spent maybe 10% of our time writing code and 90% engineering. But now that 10% is gone, the AIs write that for us. Thank you for the likes. So use the tools that make you happy. You don't have to worry about any other tool, or like, hey, this other tool makes me XYZ more productive. Just use the tools that make you happy. Guys, he has 884 videos on teaching. I do, Ghost Chat. You're totally right. I didn't even think of that. Let's see. YouTube/Stephen. How many videos? You're totally right. Yep, 884 videos. Whoa, look at that. We got some videos there. Look at so many. I didn't know that's a lot of videos, you guys. Wow. We got a lot of videos. We need more subscribers though. We need more subscribers, you guys. We're almost to 6,000 subscribers. We need more subscribers. All right, here we go. All right, let's see here. You accept the color scheme? I like the color scheme. I use Groovebox, my color scheme. Groovebox. There we go. I like Groovebox. Sublime makes me happy. Cool. Mohammed, use Sublime. Sublime is a great text editor. Formalist means you believe maths are just meaningless symbols, and Platonism believes that mathematical truth exists independent of our acquiescence with the theme. What are you saying, Cyber Potato? I think you're describing some philosophy, is what I think. Hey, PK Sharma. How's it going? All right, let's see. We only have about 20 minutes left here, and then I got to get going. So I got to make sure this works. Let's see if we can make it happen. We need to solve this part right here. I need to think really hard on this, you guys. I need to think really hard on this. Is this outputs I.transpose? Because we did that here from the gradients, but maybe what we do is do self.input.transpose. I think is what we do. I think this is what we do. And we don't need to say we're going to do like this. We're going to use the dot product like this, like that. There we go, like that. We're going to make it simple. You guys, like that. That's what we're going to do. Can LLM be coded the same way as we code other neural networks from scratch? Yes, Mohammed, you got it. The current neural networks can rewrite themselves. They can. And also you want to use something, use PyTorch transformers. And then the AI can write its own code that can regenerate itself. Isn't that cool? I guess that's like what Turing complete. It's like what defines Turing. It's nearly Turing complete. Okay, maybe I should rephrase or phrase it better. Mate, what exactly does your firm contribute to society? Oh, is it good? Yeah. So what my firm, pubnub.com. So we are a communications platform company. We enable you to add communication into your device, in your apps. So if you want to build a multiplayer game or telemedicine or chat or watching a map update with a car on the map update as it moves across the map, that's what you use our technology for. Games, support. Right? Support. It's basically communication between devices is what we do. So I do, let's see here. Go to developers, go to SDKs, go to JavaScript. And then you initialize the SDK, and then you can subscribe, or you add your listeners. So a message handler. So that way when data arrives on the device, you need to be able to capture that. And then you can subscribe and then you can publish data and it's all based on channels. So where is it? Here you go. So channel hello world, and then you can send any kind of data that you want. Any kind of data that you want. Do you build apps at PubNub? Yes, we do. Absolutely. We build apps, and we help other people build apps that need to communicate. We help other people build apps that need to communicate. That's what we do. That's what we do. Anyway, Julia is made for computation, matrix, vector, and linear algebra is built on. Oh, is it? So Julia is actually pretty good for that. Also, you can apply whatever function with function.name. Oh, sweet. Yeah, you just have to add the dot. Okay, Stephen, I am a third year college student searching for internship. Give me some tips for that. PK Sharma. The best tip I can give you is to just keep applying as many times as possible. That's it. That's just apply to every possible role, and it's a numbers game. It's a numbers game. You get in, or you don't. But if you don't apply everywhere, you're leaving an opportunity on the table. Is it possible for a person to build from the ground up an AI software to becoming wealthy? Yeah, it is. People are doing it all the time. Here, the answer is, it's called function calling. So function calling, OpenAI. Here you go. Function calling OpenAI. This is what you want to do. Learn how to use this and then build a business on it. You can automate anything. You can automate absolutely anything. And then you can make millions of dollars. I'm not even kidding. I actually want to do this at some point later as a future project on stream. On stream, we'll do this. We'll build another business, but not for a while because I'm too busy these days. I'm too busy. Hamja from India. Okay. Science. Why do we need to learn math proofs for computer science? You don't, Cyber Potato. You don't, because I didn't, and I'm doing perfectly fine. I'm doing perfectly fine. Okay, so we got like 10 minutes left, and I want to finish this program. Do you build blockchain apps? I don't. Ghost Cat, I don't, but I know how to. I know how to build a consensus algorithm that's distributed. A distributed consensus algorithm. We could do that. There's a lot of ways to do it. Why do people say a proof is a program? I don't know. I mean, you can build a proof in a program. They're maybe one and the same, but they're not mutually exclusive, right? Because you can build a program that's not a proof. Any free AI agent creating app. Any free? I don't know. There's I guess Quinn, right? Isn't Quinn coding agent? Maybe do Quinn code. I think Quinn code. Something like this. Free coding agent. Boom. Free coding agent right here. And then you can run it on your local hardware. You can run it yourself. And it does a pretty good job. Teach us. Ghost Cat, we will, maybe someday we'll teach you. That'll be a future stream idea. I'll put it in Discord. Future stream idea. Let's do this. Bunch there, and then go here. And we'll call it build a blockchain from scratch. I think that'll be fun. That'll be a future stream idea. A future stream idea. There we go. Okay, so that's in. Did I spell blockchain right? Block with that. We've got to spell it correct. Chain. There we go. Blockchain. There. Done. All right, perfect. We got it. That'll be a future stream. Okay, let's see if we can get back to this. Holy snowmoly, that is amazing work. Bruv, do you Vive competitors or command monopoly on the market? We are the number one. We are the biggest in communication. We've already gotten over 1 billion connected devices as of May 2023. As of May 2023, we have 1 billion connected devices. Yes, we are number one on the market. Have you done internship? Yes, I have. Movies for Everyone. I did an internship, and it was an unpaid internship. An unpaid software engineering internship. I did it. But that was many years ago. When do you go live again, Ghost Cat? Every weekday. Every weekday, you got it. We go live every weekday. Dude, function programming is cool. It is. I love functional programming. So basically, I need better hardware for local hosting to prevent prying eyes. There you go. Your space now. Here we go. You got it. Why you say you can make millions with function calling GPT? Yes, because you can automate. Here's the deal. Okay, are you ready for this, Gritchmeyer? Or Geechee Main. Geechee Main. Are you ready, Geechee Main? You can make millions of dollars using OpenAI function calling because today there are billions of dollars spent on software maintenance for legacy systems. Going forward, we need to turn all of those legacy systems into artificial intelligent operated systems. You can do that if you're familiar with all these AI agents out there. You're hearing all these AI agents. We have an AI agent for this, an AI agent that can write software, an AI agent that function calling is basically how you make AI agents. So you can automate any workflow using a deterministic output, which means that, these AI systems, they give you a whole bunch of text. Well, function calling gives you a way to interface with those systems that can think and process using a deterministic output in a very specific format that you get to pick all on your own. And that gives you the capability to leverage these intelligent systems in a box to build automatic new systems that take over all the legacy. There you go. Millions of dollars right there. So you can do it. You can do it. Time? What time? Biggest time, you have to, it's different every day. So you have to subscribe for the notification, but it will be around this time every day. Where are you working? From Seattle. I'm in Seattle right now. I assume I was a recent startup, but seems like you've been around for a few years, Mr. Lamb. You're totally right. We've been around for almost 15 years. 15 years. All right, let's see if we do we do it? Did we finish? No, we need to finish the bias here. We got to finish the bias. Okay. So I think actually, did we do this? Is it done? Did we get it? Are we done? Let's run it. Let's see what happens. All right. Are you ready? Thank you for the likes, you guys. Oh, we might have got it. Let's see if it works. We spent so much time talking on stream, and do we have a program that actually works? I don't know. I don't know if it's going to work, but we don't have much time left. So thank you for all the likes, you guys. Here, we're going to see if it actually works. Here we go. All right, let's see. We're going to see if it works. All right, here we go. Python ML. Is it going to give us an error? It probably will. Oh, it almost worked. I know what the problem is. There's a C out somewhere. C underscore out. Where is it? Oh, our first gradient. All right, there we go. Thank you for the likes, you guys. Can you give me a referral and network engineering team? A referral? Like, what do you mean? It depends on what you mean by referral. It depends, movies for everyone. It depends, movie. Ghost Cat, it will. Wait. Assume around for a few years. What do you mean? Ghost Cat, I'm trying to, where? Oh, it will work. Yes, it will. Thank you for the likes, you guys. All right. So it almost worked. Okay. We're fixing the errors. Here we go. We're going to try again. Where's it going to work? All right. So far, so good. All right. We have another error. We're going to fix that. Where is it? We only have a few minutes left here, guys, and we have to make it work. 45. Go. All right. So it's got a problem right here on this line right here. All right. Layer object has no attribute derivative. All right. So derivative. Thank you for the likes, you guys. All right. We do have a derivative here. Derivative. Here we go. Derivative. Self.derivative. I might have just spelt it incorrectly. I did spell it wrong. Here we go. Derivative there. Okay. And then the first gradient. All right. We got gradient there. Okay. Now, is it going to work? Look, you guys. Look. Oh my God. There are no errors. Is it going to learn? Did we do it? Are we successful? First, get status, get add ML. All right. And then get commit -m, code complete and runs without error. But is it going to learn? Learn. Is it going to learn? I don't know if it's going to learn or not. There we go. Oh, I got to spell commit correct. Commit. There we go. And then we're going to push math. Nope. Push main. We got to push main. Push main. There we go. All right. Is it going to work? I don't know. We're going to find out. 15. How is that? I've never heard about people who've never witnessed any advertising or promotion from your part because marketing is hard. Do you solely take contracts with MNCs? No, we're trying our best. We have the world's best technology. I've got patents. I've got over 60 patent claims and over multiple patents. You can see on my LinkedIn. I'm not kidding. I'm serious about it. We've got the best technology for communication between systems. So I've got my patents here. A lot of claims in the patents. You can even see here on the Google. You see all the patents and all the different claims. We got lots of systems, you guys. A lot of claims. So claims. Here we go. 20 claims in this one patent alone. We got 20 claims in just this one patent, you guys. Did you know that you can have multiple claims in a patent? Yes, you can. You can have 20. And this is my patent, you guys. This is my patent right here. I'm not even kidding. I'm dead serious. All right. But yes, you're totally right. 15 years is a long time to go without having been... I know. It's after 15 years, it seems like everybody should know. We just got some issues. Could you use MPL to visualize the data? You could. You absolutely could. Should I learn Python? Eddie Legendary? Yes. Python is the world's best premier language, I would say. The best premier language because AI. Because AI, thank you for the likes, you guys. I appreciate it. You can see all the heart icons show up there on screen. Do you think China is a serious competitor considering the U.S. best in terms of hardware capabilities? Yeah, China is a serious competitor. Thank you for all the likes. I appreciate the heart icons. Interact with Chinese tech savvy and they have DeepSeek. You got it. They've got DeepSeek and Quinn. So there you go. There you go. Okay, is it good now? Okay. Sometimes the subtitles, they pause for a second. I thought of joining the Navy, but I feel like I should code again. You totally should. Movies for everyone. You should code. Eddie Legendary, IDK, what happened? But hey, yeah, Python, learn Python. Okay, so it seems like it's working now. All we have to do is okay. So I think is it really working? Is it really working, guys? Did we? Oh wait. We didn't even optimize it. So we have to run optimize. When do we optimize? When do we optimize? Should we just optimize here? Because we got the gradient there. We should just do this. Self.optimize. We have to say self here. There we go. Thank you for all the likes, you guys. Here we go. All right. We got to spell optimize right. Is that how you spell optimize? Optimize. Wait. I want to spell... Can I spell? I can't spell. Thank you for the like. I'm going to spell it correctly. Optimize. There we go. Yeah, that's how we spell optimize. Okay. Here we go. Optimize. All right. Optimize. Optimize. There we go. Is there any other thing for all the likes? 60 independent. Yeah, I know. Independent. No, patent claims. 60 independent patent claims. Multiple patents, but different claims. So you can have multiple claims in a patent. Yep. No wonder there's no budget for marketing mate blowing it all on the legal team. I know. It's actually, it is expensive, but... thank you for all likes. Appreciate it, you guys. Can you explain C++ in AI versus Python in AI? They're the same. I mean, it's the same algorithm. Python is just easier to use, and we're using a library called NumPy that's making it even easier to read. NumPy helps because it takes care of iterations. It takes care of iterations for us. So it does a really good job. AI is mostly Python because it is easy to work with and has tools that make it fast. You got it, Benedict. All right, let's see if we got it, you guys. All right, so we did optimization. We got our gradient. I think, all right, so I've got like 5 minutes left and then I got to get going. 5 minutes left. Okay. All right, so we optimized. Is it going to work this time? Python, let's see, Python run at get Python. Okay, so here we go. We got a problem with the shapes. Oh no, I knew this was going to happen. I knew we were going to have something. I knew something was going to go wrong. All right, we might have to do optimization in a future stream. We might have to do optimization tomorrow. But we did do backpropagation. So we've got our gradient, and then we return the gradient, and then we have save the gradient, and then we return the next gradient. I think that's how it works. I think so. Self.input. We might need to do some, so I see a problem here. The first layer needs the input to calculate. So that's one of the problems. But did we do it here though? Is this it? I think actually we're fine. I think we're fine because we have it here. I think we have it. So we don't have that problem. That's not a problem. Are you making the whole thing using NumPy only? What a Chad. It is 100% NumPy and nothing else. Nothing else, you guys. And no AI to help us either. AI is turned off. Fast to work with. No need to compile. You got it. Python, there we go. Is amazing. Sir, bye-bye. Mr. Lamb, I need to head out. Upcoming football match in a few hours. Must go. Warm up. Lots of live. Thank you so much, Mr. Lamb. It was great to have you in. Worldbox noob, what are you doing? Today we built a machine learning framework from scratch, and on Friday we did forward propagation, which is the easy part, and today we did the hard part, which is back propagation, and we almost got it working perfectly. We just need our optimization layer to succeed. And I'm almost out of time. I really want it to work. What are the requirements and specifications? Worldbox is no AI. We're not using AI to help us write any of the code, and we're doing it from scratch, and we can only use one library, which is NumPy. That's the specifications. And we're doing it using the XOR operator, which is very easy proof of concept, non-linear equation that is needed to solve or train a model based on an XOR operator. So that's what we're doing. Requirements, computing device. Yeah, you need a computing device. That is the requirements. Computing device, Benedict. Benedict is funny. Benedict is making things. All right, Eddie, legendary. I know a bit of batch. You know what you mean bash? Do you mean bash or batch? But I'm not good at so much fun with Python. Python seems fun. Yeah, Python is great. It's very easy, simple, clean, easy language. What about trading using programming languages for analysis? Yes, Melody of Draco. Now you're talking. You can, and it's worthwhile. You can totally make profit there. I've done it before and have succeeded, but I decided to spend my time on other things that I can gain even more value. You cannot predict the markets. You could do a trend analysis, but it's often too late. Yeah, you're always trying to be ahead of the curve. You can get close, and you only need really to be 51% accurate, because if you have that extra 1%, then you can profit 1%, right? You can profit 1% extra. Losing 50%, but then you can gain 51%. So if you lose 50% but gain 51%, that means you've gained 1% net. So you can do it. You can totally do it. There's ways to make it happen. That's it. All right. We're running out of time. You guys. So let's see if we can get this to work. Let's see if we can get it to work without error. Non-broadcastable output. The learning rate on the bias. So the bias. All right. I need to say here. Okay. Let's try this. Let's go over here. Let's close this for a second. Let's close. Did you read Math for Deep Learning by No Scratch Press? I did a little bit to help understand what's going on behind the scenes and how it works. I read a little bit of math, just a smidgen, but for the most part, you're just doing regression, but at a high scale. You're just doing regression, but at a bigger scale. Batch. .bat. Batch files. Batch is so not bash, but batch. Eddie Legendary is really easy. It basically commands to code in Notepad. Yeah. Okay. So that sounds like maybe a Microsoft programming language of some sort. Like it's like BASIC or Bash, but it's called Batch. I think I remember .bat files way long time ago. That's a really old technology. Like Eddie, it's very old. It probably still works really good though. It probably works perfectly fine. Okay. So this is the problem here. So let me comment this out really quick. Let me see. Let's go like this. Let's do like this. Okay. And do Python ML. Is it going to work? Okay. So we just have to solve the error on this line. Yes, Eddie, it is. It's pretty old. Okay. Let's see here. Let's see if we can fix this really quick. And then I got to get going. You guys. All right. So, let's do this. Let's do print. We'll call this, this. We'll call it this. Here we go. We have to do it like this. Okay. Let's see. Nope. No. Okay. There we go. Okay. We'll print that. And then we'll print the actual value of it. And then we'll comment that out. Okay. And then we'll see what that looks like. Didn't you know Batch was an actual language? I only used it and start my Java applications. Yeah, those .bat files, you guys. All right. Thank you for the likes. Okay, Python ml.py. Okay, here we go. I need to see the screen a little bit better, so let's close this window. Here we go. Let's see what's going on. All right, that looks perfectly fine. Why is it an error, you guys? Thank you for all the likes. Appreciate it. I stretched I stretched it up to over 40 years old. It's a wow. You got it. It's super old. Does programming help in securing your privacy? Because now the internet became full of scammers. And what about Web3, the new internet? So Web3 really isn't a new web. It's still the internet, and it's still all over. Web3 is just a concept of a new stack. It's a new stack. So it's like, instead of using traditional enterprise compute on servers that you lease compute for, like Amazon and Google and Microsoft for Azure and GCP and AWS, you can use the blockchain to do your entire stack for you. It's still running on these traditional enterprise systems. Don't get me wrong, but it's an abstraction. It's a framework. Web3 is a framework that lets you code in a new way in a distributed, decentralized fashion. So you no longer have to worry. It's like the true serverless. So you you don't have to worry about where your computing resources come from. You just put your code onto the blockchain and your app is ready to go. And that's kind of how that works. Web3 is not a new internet. It's still using existing internet. It is just a framework. That's all it is. IDK, but you don't know if it's language, but it's fun though. Yeah. Batch could definitely. Thank you for your likes, you guys. I need to choose between AWS and Azure. What do you think? They're both good. They're both very good. We use both. So if you're gonna pick, Azure is a little easier to use, and Azure is a little easier. EC2, it requires extra steps, but they both work just fine. You guys. Thank you for the likes. Okay. So let's see if we can solve this. I'm past I have to go, but instead I'm going to take it right up to the edge of my next meeting, which is at the top of the bottom of the hour, which is 1:30 p.m. here. So I got to go at 1:30 p.m. So that means we have 10 minutes left, you guys. We got 10 minutes left. So by ml.py, here we go. So you see, thank you for the likes, you guys. We're here. All we have to do is figure out how we get this. Let me print out the bias now. There we go. Print. Let's do this. Self.bias. Here we go. Oh, wait, hold on. Copilot it's got to Copilot disable. There you go. No AI coding. We got to turn that off. Thank you for the likes, you guys. Okay. So now let's actually print the bias. Here we go. Print bias. There we go. And then let's run it. Let's run the program. I'm just going to run it in another window. Here, let's close this. Python, ML. Okay. So let me see. Bias looks like that. Oh, I get it. I see the problem. Do you guys see the problem? Where can I get cheap GPUs? The answer is to lease a GPU from a cloud vendor, and they will allow you to rent them for about $1 per hour. $1 per hour sounds like a lot, but you might not need more than a couple of hours. You only spent a couple of dollars, and that's it. You don't need to purchase the GPU for thousands of dollars. You only need to rent it for a couple of hours for a couple of dollars. So you can do it on Azure, you can do it on AWS, and you can do it on Google Cloud. Or Alibaba. You could do it there too. There's a lot of different places. I'm also doing backpropagation with Rust and ND Array. Oh, cool. This inspired by you, Stephen Fire. Thank you, July. That's actually really cool. I want to try that. I want to do that. That'll be Rust. It'll be my GPT can outcode you. You're totally right, Rabbit. You're totally right. That's what these things, but we're doing hard mode so we can learn. So we can learn. Do you guys see where the bias is? Where the problem with the bias? I figured it out. So we have to do it like this. I think we have to do it like this. Watch. 1 comma. There we go. That solves the problem. I'm pretty sure that was it. Was this before? And now it's this, right? So there we go. Before. Now, we're good to go now. We're good to go. It was just this right here, I think. Let's find out. Okay. Let's see if it looks better. Let's rerun that. Okay. Now it looks good. Okay. So you can see the dimensions look good. So you can compare these two. See the comparison between now they've got the right dimensions. Though I think that's fine. I just don't know if it's going to work properly. I don't know if that's going to work the way I want it to. It may. We're going to find out. We're going to find out. You guys, do you prefer Windows or Linux or Ubuntu? I'm on Mac OS. I like Mac. Do you know? But all Linux or Mac? Linux or Mac? Linux or Mac? They're both of the two. Those are the best. eBay, but a lot of sellers do you favor by removing their chips. Oh, so you got to be careful about if you want to purchase the GPU to have in your house. Benedict makes a good point that if you buy it on eBay for a low price, you might not be getting what you bought. You might not. I'm a sub. Hey, cool. Thank you, Eddie. Appreciate it. And I need to go. So bye. I was happy to see you here in Eddie. Windows, but Linux subsystem. There you go. Benedict has your answer. You can be on Windows, but use Windows Linux subsystem. WLS. Windows Linux subsystem. There you go, you guys. All right. I think we've got our answer. So we can uncomment this now, and it will work. It will work. Let's see here. Let's try it again. Is it not going to crash? It didn't crash. It didn't crash, you guys. Okay, here we go. Let's get rid of all these print statements. All we have mac and cheese. There you go, mac and cheese. That makes me hungry. I'm missing lunch right now. I'm missing lunch. All right, let's see. Let's do 10 epochs. Let's see what 10 epochs looks like. Is it going to do good? It looks good. Okay. All right. So now all we have to do is print out the loss. I don't want these guys anymore. Let's see. Print the loss. We don't need the delta. We don't need to print the out. But here we go. This is the last thing we do, you guys. Here's what we need to see. We need to see a number on the screen. That's a floating point number that is decreasing. We need to see a number that's decreasing. That tells us that we did a good job. That tells us we did. Do you think we're going to see it? Hey, how's it going, Echo? Echo, welcome on in. We just built ourselves WSL. Yes, Windows Linux subsystem. We just built from scratch our own deep learning framework. We finished backpropagation and the optimization layer. We did gradient descent. Is it going to work? So all we have to do, we're doing one print statement here. If we win, we win. If this number is decreasing. So we've got the good and the bad. So we want the number to approach, so decreasing, approaching like a low number. And then bad is if it goes above. So this is what we need to do. Is it going to work, you guys? Do you think it's going to work? I don't know. Here we go. We're going to find out. Print. Did it work? No. It didn't work. We got a problem, you guys. All right, let's try it. Let's do like 1,000 epochs. Here we go. See, okay. Epoch, it went to 0.5. Oh. Is it working? I can't tell. It's too fast. No, it's not working. All right, we've got a problem. It didn't work. Oops. Yes, IDK, what's going on? We built a deep learning machine learning framework from scratch. That doesn't work. That's what we did. We did it. It doesn't work. It does not work. Okay, let's try again. Does it work? No, because see, it always ends in 0.5. So we have a model. Maybe it's possible. See, it's not decreasing. It just diverges. It matches. It stops at 0.5. So that's the problem. So as you can see here, it seems to be increasing. So it increases to 0.5. So it tells us we did it wrong. You guys. Okay. So this is, try more epochs maybe. MSC, slow it down. Oh, like fewer, lower the learning rate. So lower learning rate, fewer epochs. Okay. Let's try that. Is it decreasing? It's still increasing. 48 and then 48.3. It's still increasing. So 4.9. So this is what we need to do. It's not decreasing. Yeah, it's not decreasing. So maybe what we could do, negative equals. We're not going to do it. We never know. You never know. All right, let's try it. Did it decrease? It's decreasing. Was that it, you guys? Is that it? Is that all we had to do? Oh, I think maybe. Okay, hold on. All right, here. Let's do more epoch. Wait, let's bring the learning rate up. We'll do 100 epochs. Okay. Do you think that's all we needed, July? Do you think that's all we needed? Dude, look, oh my God. Oh my God. Oh my God. Okay. I think we did it. I think we did it, you guys. I think we did it. Oh my God. Look. It's so cool. We did it. Oh, I'm so happy. You guys, this is like an ultimate relief. Over this weekend, I was like, I'm going to be doing backpropagation live on stream on Monday. And I was like, what if I don't get it to work? What if I don't get it to work and I fail completely? This tells you at least, it's like this like relief. It's like the reason. Thank you for all the likes, you guys. We did it. Look at July. Check it out. It's decreasing. We did it, you guys. Yay, Echo. We did it. And we also did it on the right time too. Yay. Isn't that cool? I was so worried about this. I was like, you guys, what if I failed? What if I failed and I just didn't make a machine learning model? I was like, I can write AI. I could totally do it. I could write all the AI. Like I'm telling everyone, I've done 3 neural networks in the past and I could totally do it. I was like, but what if I couldn't? What if I forgot how to do it? Melody of Draco, thank you so much, you guys. Thank you for all the likes. We did it. We taught the model. We're training. What we'll have to do is show you how to use the model. We'll have to use the model tomorrow because we're out of time. Do you still use Stack Overflow? A little bit, maybe very infrequently. Thank you for all the likes, you guys. We did it. We did it. What are your thoughts on AI Copilot, Grok, ChatGPT, and coding problem? We need to be using these AIs to write all of our code for us going forward. We just did a hard mode today. We wrote everything from scratch. We did it all from scratch. All this code here is from scratch. I'm going to commit this to Git. I'm going to push it up to our GitHub repo. We did git add ml.py, git commit -m. We did it, and then party popper. We have to do some party poppers. There we go. Party popper, and then another party. Oh, you got to do 3 party poppers. There we go. We did it. Push to main branch, boom. We did it. There you go, you guys. Yes, gradient is to subtract because you move the opposite direction of the loss of the growth. July, we did it. We totally did it. It was, I know, right? It's like, maybe if we do, like, if we just change we saw a few errors and I luckily was able to figure it out. We did it, July. We did it. Everyone chat. We did it. It was so cool. Oh, it's just such a relief. Here's why you software engineer. This is the reason right now. This is why you do it. Thank you for all the likes, you guys. This is why. I'm happy. Me too, July. We did it. We figured it out. Thanks, man. Yes, we did it. Oh, Stack Overflow is here to Google and center of the div. Yep, center of the div. You still got to figure out how to center that div. We did it, Echo. We did it. We did it, everyone. Okay. So it was great to hang out with everyone. We'll wrap up the stream here. We got to end. What we're going to do tomorrow is we'll use the framework that we built. We'll use the framework that we built to, we'll figure something out. We'll come up with some sort of something. We'll do it. I just got here, but me so happy. You're so happy too, Echo. You did it. You came at the right time. This is the reason why we do software engineering. This is the reason. We do it. This is why we do it, you guys. This is why we do it. Okay. So we succeeded. As you can see here on the screen, the numbers are decreasing. The numbers decrease. They start out at halfway and then they decrease over time. You can see what I want to do is to get rid of that for, let's see, print here. Let's go back down. I want to not have it print out this. I don't want to print that. Let's get rid of that really quick so that way you can really see it working See, look at it. If you can read it on the screen, when the numbers decrease like this, that means that you're learning. The loss is less. The cost is low. The loss is lowering. We did it. All right. Thank you, everyone, for joining today. We'll be live again tomorrow. Tomorrow, we will be using this framework for something. I don't know. But we built it, and we did a really good job. I'm really satisfied for this. I'm so happy. We can improve this a bit more because we can turn we can make another object or another class and put these layers into the class. So that way we don't have to do things like this where if we want more layers, we can just say number of layers and we're good to go. So there's a whole bunch more things we can do. But look how tiny this file is. Look how tiny this file is. A full deep learning machine learning framework in less than 100 lines of code, but we can make it even smaller. Isn't that crazy? Thank you so much for everyone for joining today. We're going to end here. Tomorrow we'll be live. Subscribe to get the notification when we go live tomorrow, and we will be we'll be using our framework tomorrow for something cool. Thank you for hanging out with me today, everyone. We'll be back tomorrow. It was good to see you. Thank you, everyone. Bye, everyone. See you next time. Tom Collins, thank you for the party poppers. It was great to see everyone. We'll be back tomorrow. Here we go. Awesome. Yay. Cool. Thank you for joining, everyone. Back tomorrow. Bye, everyone. Bye, Chusher Pinto. Bye, Benedict. Could you program it so it figures the best neural network settings to size learning? You actually, that's a really good idea. You're doing some meta programming there, aren't you? Bye, everyone. Great session, Tom Collins. Thank you. All right, see you guys tomorrow. Bye. Here we go. Clicking the go bye button. Here we go.